Hi, Al Williams here. Another quick and dirty video on the 1802 Fourth that I've been working on. Mike Riley did the original version, and I've kind of taken some changes that Mike Jolly made and gone a little bit further with it. So actually, I have to say quite a bit further now because I've been working on it for a little while. And I thought I'd show off some of the newer features. One of the things that I've changed is how the word system works. So you'll notice there's core words. These are the ones that have binary tokens. And then there's user words. Well, those are ones that are loaded. They're built at compile time. It's what was the B-load words. But there's actually a couple of differences. B-load words were hard to put together. And pardon the mail chimes. I told you it was quick and dirty. But the B-load words were very difficult to deal with. It was basically a dump of the entire RAM region that was pertinent anyway. For once so you basically set everything up and dumped your RAM, and then that's what got loaded back at runtime. Well, that's great until you change something, right? If you change a token, or if you change variables in the code, in the assembly code, not in the fourth code, or even if you relocate it, right? So you say, well, I'm in a different system, so my RAM's down at 8,000 now instead of at 0, so that screwed everything up because there were actual pointers to RAM in the blocks. So it was really a discouraging pain to go and change anything in there, or add something, delete it, or edit it. So I've changed that. There's a couple of inc files now where you can put in 3 different sets of words, and they can be put in as simply as using ASCII text. However, that's wasteful of ROM space, so you can also use tokens. There's examples of that at GitHub where you can say, F colon for a colon, and that's 1 byte. And you say, well, a colon's also 1 byte. But if I say F variable, for example, that's 1 byte, and a variable is not 1 byte. So overall, it saves space, and you can freely switch back and forth. So you can have a definition that's all tokens, or all a string, or you can just slip out of the strings into strings when it makes sense and out. So for example, sometimes if I want to put a 0 in something, a numeric 0 is shorter than putting a numeric token with 16 bits of 0 after it. That's 3 bytes. And I can just put an ASCII 0 in the mix, and I've got a 1 byte 0. So I kind of flip in and out, you'll see if you read the source code. So the 3 groups that are loaded from there is there's actually a core bunch of these user words, the very first ones, and they're things that you really want to use all the time, like hex and decimal, unloop, rdrop, things like that you know you're going to need. And then there's other things that get loaded from a custom inc file. So for example, these breakpoint macros are from my custom file. They're not actually in the GitHub distribution. But then there's also a bunch of words that are in this extended set. So what'll happen is, let's just do this. If I say new, well, when I start up, everything loads up. And by default, you can change that, but everything loads up. But if I do a new, it'll say wait. And that file, by the way, can not only just define functions like it used to, now it can actually execute things. So not only did it load my custom stuff, but it also, in custom, there's an init word, and it calls the init word at the end. So if you were doing some turnkey system, for example, you could have it launch your system, or like my init switches me over into hex mode automatically. So if you look, now I have some user words, but not all of them. I don't have the extended set because I did a new. These are the ones that just always get loaded. And just like before, I have to do a B-load to get the rest of them. Now, it used to be a B-load would wipe out everything else, but that's not true anymore. When you do a B-load, you just get the words added on to whatever you're already working on. So that's kind of nice. The other thing is when you define a word now, well, first of all, you can do a Control-C, and that works. That's nice, especially because I've added something, which is multi-line word definitions. So if you're in the middle of a word definition and realize, I've gone too far, you can hit Control-C, and that'll just blow you back out to the prompt and forget what you were doing. So that's nice. But let's look at that for a minute. If I said double, and I actually can put proper comments in here. I think that's a proper comment. I can also put backslash comments in. Let's do that on a second line. And so you'll notice my prompt is :OK. That allows things like the uploaders to not get confused about the prompt, but it tells you, hey, I'm in the middle of a colon definition. You can't type something and expect me to do it. I'm sticking it into the double word that you've already started defining. So we'll say 2 times, and I'll put one of these comments in here, double user number. Stupid comment, but that's okay. And then, oh, well, I forgot to terminate it, so I need a semicolon. So there you go. There's 3 lines. Now, it doesn't actually store the comments because we just don't have that much memory. And you say, well, why do you have the comments? Because if it's in a file, it's very handy to be able to put comments in the file to explain things. So when you're looking at the file, you don't go, gee, what's that, 48 characters there that I've got here? I wonder what they meant. I've forgotten. Well, now you can put the comments in, and you'll see them in the file. And you'll see them when they load, too, but you won't see them here. So if I say 10 double, now let's say that this doesn't work for some reason. It does work, but let's just say it doesn't. Here's something else that's new. It used to be I could go in and define, let's say, a temporary word. I'm going to say double 2, and I'm trying to figure out what's on the stack at this point. So I'll say .s star dot. Okay. Now, in the old system, you could do this. It would make another word called double, but it would never find it because it starts at the beginning of the dictionary and it goes until it finds something and it stops. That's good for efficiency because you don't have to look through the whole dictionary every time. A proper fourth would start at the end of the dictionary and work its way backwards. That's hard to do. I'm not going to promise I'll never do that, but for now, I haven't done that. But it still works. I got a lot of junk on the stack for different reasons, but here, let's clear that off and we'll do it again. There you go. So it found the last one. And the reason for that is we now search the entire dictionary and we take the last match. Now, that's not very efficient, although as you could see, it's not terrible. I mean, it's not like it took 5 minutes to find double. It just took longer than it would have taken if there'd only been one double. However, there's options now. So there's a variable called options. Right now it's 0, and there's a bunch of different options. One of them is option 2, and these are bit fields, right? So 1, 2, 4, 8, so forth. But option 2 will set it to where it looks for the first definition, not the last definition. So notice I don't get a .s anymore because I still have that definition. I just don't have to find it because I find it first because of that option being in effect. And if I go back to this option, now I get that one. The reality is you shouldn't do this very often, but sometimes during development it's convenient. But you would never really do this if you were trying to do a production system. Let's say I've got a bunch of words and I plug them into one of the ink files, I recompile, I make my init word start my, whatever it is, weather station word or whatever it is that I'm trying to deploy. Well, then I shouldn't be adding multiple copies of the words, and I should just stop at the first one I find. And that's great because you can stick that in the options. Meanwhile, if you like it the other way better and you don't want to ever do it this way, well, that's fine. In your init, you could set that option bit, and that would be fine. There's a bunch of other options as well. So if you had, say, some hex numbers, let's say I had v0.5, that's a high part and a low part, and I want to print it as 2 pieces. If I just do this, it's got a space in it, and there's not really any convenient way to get rid of that space. You could write something that like pumped it out into a buffer and then loop through the buffer. It's a lot of work, right? But if I set option 1, and of course obviously these are bitmaps, so you could set more than one option at a time. But if I do that and I do v0.20, let's put a space here. Oh, my space didn't work, but I get v0.20. Oh, you know why? Because I didn't omit the space. But I get v0.20 all run together, and because I failed to print the space that I put at the end, the OK ran into it as well. So just for completeness, something like that. Another thing, speaking of omit, is you can actually put in character constants now. So you can say something like, there's F, right? Or there's a $sign. So you don't have to remember the ASCII codes for things. That's a small thing, but it's certainly handy when you're writing code. Now, the other options let me do a couple of different things. I've tried to make this more like a regular fourth. Let's clear the screen. Did I leave those words in there? Yeah, let's forget those words just for fun. And I have to do it twice. I also have to spell it right, because there's two of them now. And so when I delete one, it left one of them. Which one did it delete? Well, it depends on if I'm looking for the first one or the last one, but it'll delete either the first one or the last one based on that option. But if I make a variable, it used to be everything got compiled into your work area. And so if I made something and said like variable XYZ 10 a lot, this was very dangerous because it would write over part of your command line. And if you weren't ahead of where it was writing over, woe betide you, right? And it would cause unpredictable behavior. Well, that doesn't happen anymore. So what'll happen though, oh, I just misspelled it. I meant to do XYZ. I did XZY. That's my fault. Operator error. You can see it actually has a create there. Create is something you can do as well, and it makes a variable name with no storage allotted to it. Then in this particular case, it allots 12 to it. You say, well, why 12? Because you said 10. But the problem is I used variable, which gives me 2 by default, right? But if I use create, it gives me 0. So to recreate this, it would have to do 12, and it knows that. So it did that automatically for us. And then it actually gave us the data to put into that array to have it back the way we want it now. Now, I hadn't put anything in there, so this is all just garbage. But had I already populated it with, say, a machine language program or table or something like that, it would be here. And if I stream that out to a file, I could keep those or I could delete them. But what if I had like a 1024 byte buffer or something? You don't really want to see all that. So that's the purpose of option 20 hex. And when I do that, oh, I did it again. It's XZY. I don't know why I did that. And there you go. It just creates the variable, but it doesn't initialize it. And that works for list as well. So if you do a list, you'll get everything. And that's really convenient for dumping the state out to a file that you can then load back in later. And I'll show you how you can do that. But, you know, your terminal can capture this, right? That's fine. Okay, I'm going to put the options back to 0. But there's two other options that are particularly interesting. But before we leave that, I want to look at arrays a little bit. If I were to say create, I don't know, array, I can do a couple of things. I can use a C comma to allocate a byte or a comma to allocate 2 bytes, and it'll store whatever I give it in that new allocation. So let's do it with not bytes, let's do it with words. If I said 1 space comma space, those spaces are important, 2 space comma space, 3, and then I need a space and a comma, and it looks weird having a comma at the end of the list, but that's what it takes. So if I do that, okay, now what happens if I look at array now? I've got 1, 2, 3 in it. And so that's a very convenient way. Like if that was a machine language program, you could do that with characters. You could say something like create MLP, I don't know, let's say 7A C comma, 7B C comma, you know, I don't know, D5 is a return, C comma. You still need the comma at the end. The C tells it it's characters. So if I do a CMLP, I'm having trouble with the middle letters today. And there it is, 7A, 7B, D5. And you notice it's smart enough, since that's an odd number, to store a character and then a store word. So it tries to be efficient. Another way to look at that would be MLP, say 10 dump. And so there's a little 3-byte thing that we put in without having to go through a lot of trouble. That really works well with the exec word, which calls into machine language. But one of the neater features, let me clear the screen here, and I'm hoping this will work. It's kind of experimental. There's a flag that will actually turn on a debugging hook. And so I'm going to load a bunch of words in here from a file. And there's a couple of things. Some of this is internal and you don't really care about it, but the things you do care about are debug on, debug off, and debug hook. If you look at debug hook, if we turn debugging on for every statement, this is going to, every word I should say, this is going to execute with some information that'll let it kind of tell us what's going on. In this case, it's debug switch, which it calls debug switch, which is a little filter I have that you throw a switch and it does like a trace and a breakpoint and things like that. I'm not going to do that. In particular, this is running on the Blackpill emulator and I don't have a switch panel on it. So what I'll do instead is I'm going to redefine debug hook to be, let's look, one of the other ones. I think debug hook NT. I think I fixed that one. There's been some syntax changes since I originally wrote this. So I'm redefining that word just like I redefined double. And, you know, as of right now, it's just normal because I don't have debugging turned on. But if I turn debugging on, look what happens. It's telling me, hey, there's a token 88, which you probably don't know, but it's a semicolon, and it tells us that. And then there's a 0, which is the end of the string, and FD, which is the end of the input string. And if I say 10.2 plus dot, let's say, and it says, look, there's a number, FF is a number, 10, a number 2, I called the plus word, I called the dot word, and I called, or it's got the end of string, FD again. So you can see everything that happened. And then you can see 12 was output. That's why those vertical lines are there, is it kind of makes it a little easier to see the output. It's still pretty hard. But that's pretty interesting, and especially because with a little work, you can write whatever kind of debug hook you want to write, and it will do that. So if you've got a more complex word, say, for example, 1F24% dot, which is actually a custom word that prints in binary. And so it will actually sit and show all the pieces of that word as it happens. And of course, if some of those words are made up of other words, it'll show you those pieces as well. So you can kind of, it's tedious, but you can actually trace and see what's really going on. There's another one that'll dump the stack out for you. And the switch one will let you pick if you want to dump any of this. It'll just run by itself with nothing, or it'll run with this kind of trace, or it'll run with the stack trace, or you can flip two switches and it'll do both. So that's pretty cool too. Now obviously it slows things down, so you don't really want to do this all the time, but you know, if you've got something you can't figure out what's happening, this is actually pretty nice. And if it doesn't exactly suit your needs, you can write your own debug hook. So you might say, well, you know, I only want to do a debug, I only want to trace when I see it's on this particular word. You know, once it hits that word, I'll turn tracing on, and I'll keep it on until later, you know, and turn it off on some criteria, so that you don't have to do like this and sit and go through 16 loops of this word with it going. So there it goes. I'm going to go ahead and say debug off, and what you will see is there's a little bit of chatter there as the debug gets turned off, and then once it gets turned off, which, gee, oddly enough, is a 40 opt store, and now it's off. See, like if I said again, you know, I don't remember what my number was, but if I do the binary output now, it's just that. I don't get any debugging. So that's actually pretty cool. Other options include, I showed you the non-spaces. You can actually change what the hex numbers. So for example, right now, if I say 2, and I output hex, it says, oh, that's 02, and it knows that it's less than 256, so it only puts out 2, but it always puts the 0 on front. But if I said something like this, it's going to say, well, that's 44, or let's do 3 digits. It'll say, well, 0144, so it puts out 16 bits. So it's smart enough to do that, and that's convenient when you have something like, say, you know, I don't know, 1220 dump. You know, that works out because the address is 4 digits, everything else is 2 digits, and it makes a nice display. The problem is what happens when you say 120 dump. Well, then it's, well, I actually have probably fixed that. Oh, no, I'm sorry. 100's 3 digits. I should have done less. Sorry. I told you this would be quick and dirty. If I do 10, okay, now, there you go. It's messed up because it says, well, I only need 2 digits for that address, but then that keeps everything from lining up properly. That could be fixed with this flag. The option to do that is 4. So if I said 4 opt store, and then I say something like, 32 $. I get 0032. Now dump would have to be rewritten to accept that as a format, so that's not going to just fix it just all by itself, but you could in fact do it with that option. Let's see, other things that are going on here that are neat. You now have an exit, so you can blow out of a word, and there's an unloop word that's actually not in the, it's in the core extended words. So if you're familiar with how to use unloop and exit to break out of a word early, you can do that now. That's nice. There's also execution tokens and execute, not to be confused with exec. So it's kind of hard to explain how that works, but maybe an example is easier. If I were to say something like this, .s, okay, that gives me a token on top of the stack, 41C. And 41C, when I execute it, will run .s. So it's kind of like a function pointer, if you will. And I can take anything I want other than a variable, but you can take a core word or an extended word and execute it, or make it executable. And the reason you would do that, I mean, there's many reasons, right? I can pass this to another word. I could say, hey, I want to add, subtract, multiply, or divide this. So I could say, okay, get the execution token for plus, and then do something with some word, and down the road it'll go, okay, now get the thing he wanted to do and execute that, and it'll do a plus. The other common place you see this would be like in have an array. So you basically make like a case statement. I could make an array of these execution tokens, and then say, oh, if it's the first thing, I'll look that up in the array and I'll execute it, and then that's like a function pointer around. So really cool. A lot of work's gone into this, oddly enough. I'm trying to think if there's anything else worth mentioning. I mean, there's just lots of different things going on here. I did move some things out, so if you're trying to put this in a ROM and you don't have a lot of room, you can cut a lot of these words out. I don't recommend you cut these out. There's also some optimizations now in a configuration file where you can pick whether you want it to be a little bit faster or a little bit smaller. It's not particularly dramatic either way, but let's see, just looking through the very end of the word list here, there's a couple of just normal things that tell you like where the stack starts and where the current stack pointers are. This .tok is for debugging. It takes those tokens like 88 and turns them into a semicolon. It's kind of hard to use. There's examples in the debug file on GitHub, but it's not as convenient to use as I would like, but it's workable, as you saw. Tib is the input buffer. Query lets you point a buffer and get a string read in from the terminal. We talked about create. Quit. Actually, quit brings you back up to the prompt and wipes all the stacks. So if you ever get really deep in something and just say, the heck with it, I want to go back to the prompt, you can do that. Anyway, this is probably going to wind up in the STG ROM at some point in the future, I assume. It is ROMable by yourself if you want to do that, and I need to write the instructions up for it, but it's pretty, if you know how to build a ROM, it's pretty easy. If you don't know how to build the ROM, it's probably maybe not as easy as it could be. And also, if you really want to have a play with it, you can go to the Black Pill on GitHub. 1802 Black is the name of it under my ID, WD5GNR. And you can actually put the whole system on a Black Pill, use it. You can also get, there's basic, the assembler, the debugger, all that stuff. It's basically like the ELF 2000 ROM. Well, it isn't basically, it is the ELF 2000 ROM with this built into it and with emulation running on a STM32. So if you ever really wanted to get a copy of the ROM, I should make those available. I think Bob has kind of given me the clearance to do so. But if you go grab the elf2k.h file off of the Blackpill stuff, it actually has, it's got the hex codes that would require going into the ROM. You just have to write a little program to convert them. But I'll eventually post a hex file up with that. Anyway, if you have questions, drop me a note. Hopefully you'll play with it, enjoy it, and either send me some pull requests on GitHub or open some issues if you find anything. I'm sure there's plenty that's not working quite right. If you've got suggestions, make them. And thanks for watching.